All right, good morning, everyone. Welcome to the Data Intensive Computing and I/O Day at ATPESC. As Ray said, my name is Phil Carns. I hope you guys have had a productive week so far. I know you've been learning a lot about computing hardware and programming models, programming languages, that sort of thing. We're going to shift gears a little bit today and talk about how to store data, how to manage your data, how to get the most out of the storage systems, and a little bit about how we're going to do that. We really want to try and equip you guys to answer some questions you may have, or maybe questions you don't know you have yet, but you will. What are the important things about HPC storage conceptually? Why are they different than other storage systems you might have used, and how should that change your strategy when you're storing and accessing data? And what kind of tools are available? There's a lot of work has gone into creating APIs and management tools and things like that that can make your life easier. We'll give you some strategies for how to use those most effectively. And finally, what can you do in your applications specifically, like from a coding point of view, to access your data more efficiently? And we're going to do this by kind of going from a high level to a very detailed level as the day progresses. So I'm going to give you some introductory material in just a little bit here, and we'll have some system walkthroughs, what architectures look like. We'll cover some instrumentation tools so you know how to manage, how to look at your applications, how to measure them and see what they're doing, and we'll refer to that through the day, and how to move data around. And after our lunch break, we're really going to get into the nitty-gritty details. If you're programming your application and you're trying to figure out how to access your data the best way, we've got some of the most popular I/O libraries that you might want to use. We'll talk about those and give some really specific examples. And then we'll go into how to kind of techniques and methods for measuring and tuning your applications and getting the most out of them. And we'll have, of course, some discussion time at the end of the day. But a little bit about your lectures. We've got 6 lectures today, so you'll get some variety of kind of perspectives and expertise as we go through. The 3 that I have up on the screen here are from Argonne, and we all work on the same research team in the Math and Computer Science division, so we have a lot of overlap in kind of what we do, but we have different focus areas. Rob Latham is our go-to guy for kind of application and storage interaction, like how do scientists actually use the APIs that they have and how can they make their codes work better. Shane Snyder is our go-to guy for kind of measuring, characterizing, understanding applications. And that's important for tuning. You can't make your application better if you don't understand what's slow or what's fast about it to start with. We're also happy to have 3 guest lecturers with us today, and they're all experienced ATPESC lecturers, so they've done this before and will be very helpful today. The first is Scott Breitenfeld. He's from the HDF group, and he's been working with HDF5 for a long time in the high-performance computing environment, tuning applications, implementing features and capabilities, porting to new platforms. So he knows everything there is to know about HDF5, so you're in luck today if you're a HDF5 user. Greg Nalraki is from the Globus department at the University of Chicago, and so he's going to be talking to us about managing data, moving data, organizing data, that sort of thing. And he's got a really broad background, doing things in science, doing things in industry, working with his own company, data analytics company. And so he really has a lot of experience with kind of how people might use data and can kind of help you figure out the best way to move your data around. And finally, Mike Brum comes to us from Oak Ridge today. He's got a lot of experience with system architectures, system software, how to make scalable tools. He's done a lot of work kind of blending kind of facility operation and research aspects, and so he's going to give us a great walkthrough of what system architectures are like that we're working with. So if you take together what these folks do, we're really trying to connect the dots between the storage technology and the science applications and figure out how to make it easier to connect the two. It'd be nice if we could just buy a bunch of fast hard drives and get some science applications and put them in a box and shake them up, but it doesn't work like that. We have to do some work to kind of make things fit together, right? And the kind of things that we do in our day jobs, sometimes we're building new data services or tuning the ones that are already there. We're operating the data facilities that you're using at ATPESC. We're trying to learn how storage is being used. We may have an idea of what we think applications are going to do, but then applications get on there and they sometimes do things differently, and we want to understand that. And part of that is kind of projecting and predicting what we need in the future. So when we build the next system, as you guys have heard, I'm sure there's a new wave of high-performance systems being built right now. What should the storage look like on those systems so that we can cater to what you guys need? And really, it's just trying to put the technology in the hands of the users and scientists. A little bit about how logistics today. You guys have been here for a week already. I'm sure you know where the agenda is. I'd like to encourage you to ask questions as we go. You can ask them live since we're here in person. Happy to be here in person again this year. We also have a Slack channel for Track 3. You can ask questions there. If we can, we'll answer it directly. Sometimes we'll relay questions to the lecturers so they can bring it up for discussion. And we also have a collection of hands-on exercises that you can try. You'll see there's a link at the top of the slide and on a lot of the slides today to a GitHub repository. If you go and clone that, it has a handful of examples and exercises you can try with some of the tools we talk about today. We have a reservation on Theta with some dedicated nodes starting at noon, but you're welcome to try it out anytime at your own pace if there's particular things you're interested in. And we'll have some dedicated time tonight for hands-on exercises, but we're not going to say that you have to go through one by one and do each thing in there. Everyone has different I/O problems and different things they're interested in. And in fact, if what you want to do is work on your code and ask us questions, that's great. We're happy to do that. So kind of use the time, how it makes sense for you. Learn about tools that you want to, work on your code if you want to, and we're here to help.